All right, so we're gonna talk more about L'Hopital's rule and indeterminate forms with limits. We talked a little bit about this at the beginning of at the end of first semester, but we didn't talk very in depth. So L'Hopital's rule, so let me just start with that theorem. And you can see this in your book as well if you want to on page 453. But it says that if f of a and g of a both equal 0, and f and g are differentiable. Oops, sorry, that went off the screen a little bit. Let me move this over. At A. And g prime of x does not equal 0, then the limit as x approaches A of f of x over g of x equals the limit as x approaches A of f prime of x over g prime of x. Okay? So I know that's like a little bit confusing talking about it in math terms. So if we just talk about it in our own words, what it's saying is if the limit as x approaches some number of f of x over g of x equals 0 over 0, and really we're also going to talk about or infinity over infinity, then the limit as x approaches A of f of x over g of x equals the limit as x approaches A of f prime of x over g prime of x. Okay? And we're going to talk about a couple examples here that will hopefully help make some sense of this. Okay? Okay, so we're going to evaluate the limit. Okay, so let's say we have the limit as x approaches 0 of the square root of 1 plus x minus 1 over x. Okay? Slide this up. Okay, so that's the limit we're going to look at. So if I plug 0 in, I'm going to get the square root of 1 minus 1 over 0, which is just 0 over 0. Okay, so I can use L'Hopital. Okay, so that means I can say the limit as x approaches 0 of the derivative of the top, which if I think about this function, this derivative is 1/2 times 1 plus x to the negative 1/2, and then the chain rule says times the derivative of the inside, which just happens to be 1 over 1, because the derivative of x is just 1, and this derivative of 1 is 0, so that's why I don't have anything here. Okay, so let's simplify that. So that gives me 1 over 2 square root of 1 plus x. Now when I plug 0 in, I get 1/2. So that is my limit. Okay, that is the limit of this. Because the limit of the function, if you get 0 over 0 or infinity over infinity, you can use L'Hopital's rule to find the derivative of the top function over the derivative of the bottom function and then evaluate, and that gives you your answer. Okay? So let's look at another one. Let's do the limit as x approaches 0 of the sine of x over x squared. Okay? So when I plug 0 in, the sine of 0 is 0, 0 squared is 0, so I can use L'Hopital. Okay? So this is equal to the limit as x approaches 0 of derivative of sine is cosine x over the derivative of x squared is 2x. And so now I get cosine of 0. For those of you that don't always remember those, if you think about graph of the cosine of 0 is 1 over 0, which gives us infinity. I forgot that my little plus sign. We're talking about 0 from the right. Okay, so this limit is going to equal infinity. All right, so that's 0 over 0 and an infinity over infinity. There's some other what we call indeterminate forms where we can use L'Hopital's rule. One of those indeterminate forms is infinity minus infinity. Okay, so we've got 0 over 0, infinity over infinity. Now we're going to talk about infinity minus infinity. Okay, so let's look at an example of that. If we look at the limit as x approaches 1 of 1 over the natural log of x minus 1 over x minus 1. Now, L'Hopital's rule only works if we have 0 over 0 or infinity over infinity. Okay? So if I look at this and I plug 1 in, I have 1 over the natural log of 1 minus 1 over 1 minus 1. So I have 1 over 0 minus 1 over 0, which is infinity minus infinity. So what we need to do is change how this function looks. We don't want to change the value of the function. We just want to change how this function looks. Okay, so the way we're going to do that is we are going to find the common denominator. Okay, so I am going to multiply this by x minus 1 over x minus 1. And I'm going to multiply this by the natural log of x over the natural log of x. Okay? So I'm going to have x minus 1 over the natural log of x times x minus 1 minus the natural log of x over x minus 1 times the natural log of x. Okay? So now that I have a common denominator, I can combine my numerators. So we have the limit as x approaches 1 of x minus 1 minus the natural log of x over the natural log of x times x minus 1. Okay, nothing cancels because we've got subtraction in this numerator. Okay, so nothing cancels. We're just multiplying in our denominator. Okay, so now if I plug in 1 for here, I get 1 minus 1 is 0, minus the natural log of 1 is 0, so I get 0 over 0. So now we can use L'Hopital's rule because we have 0 over 0. Okay? So when I use L'Hopital's rule, I'm going to do the derivative of the top. So I have my limit as x approaches 1. Derivative of x is 1. Derivative of 1 is 0. Derivative of the natural log of x is 1 over x over this denominator. I am going to have to use the quotient rule, or sorry, the product rule. So I have the derivative of the first, which is 1 over x times the second plus the first times the derivative of the second. Okay? Now we're going to have to do some simplifying, which is everyone's favorite thing to do. So we have the limit as x approaches 1 of 1 minus 1 over x minus 1 over x plus the natural log of x. Okay, I'm going to use my simplifying trick where I multiply everything by x over x because that's the denominator I have. So when I do that, I'm going to have x times 1. So my limit as x approaches 1. X times 1 is x. X times 1 over x is just 1. X times x minus 1 over x is x minus 1. And then x times the natural log of x is x times the natural log of x. Okay, so now let's plug in 1 again. So when I plug in 1, I get 0 on top. 1 minus 1 is 0, plus 1 times 0, so I still get 0 over 0. So hey, guess what? I can use L'Hopital's rule again. Okay, so if I use L'Hopital's rule again, I have the limit as x approaches 1 of 1 over, because this derivative will be 0, derivative of this is 1, minus, again, I am going to have to use a product rule here because this derivative is 0, right? Derivative of 1 is 0. Now we're going to have to use a product rule because I'm multiplying two things. So derivative of the first is 1 times the second plus the first times the derivative of the second. Now when I plug 1 in, I have 1 on top. This is looking promising. I don't think I'm going to get 0 over 0. 1 plus 0 plus 1. So I get 1/2. Okay? So, and that's my answer. You can use L'Hopital's rule as many times as you need to use it, so long as you keep getting 0 over 0 or infinity over infinity. So in this case, I had to use it twice to be able to get to this limit answer. Sometimes you might use it once. You could use it 5 times. It doesn't matter. So long as you keep getting this 0 over 0 or infinity over infinity, you can continue using L'Hopital's rule. Okay? So we're going to stop there for today, and you're going to have some homework problems that go through those types of questions.